Hello, Assalamualaikum and good day. How's your study so far? I hope that as for now you will able to do integration, the basic one, for example, indefinite and definite integral. And then we already learned the first techniques of integration, which is integration by substitution. And now let's proceed into another two techniques here. Okay, so we've done the integration by substitution. So now we are going to do integration by parts and integration by tabular methods. So please stay with me until the end of this lecture. Alright, let's start with integration by parts. So you may notice that from time to time you will experience a little bit difficult question than before. So for example, in this case, integration of x ln x dx, integration of x ex dx, or integration ex times cos x dx. So when you try to do integration by substitution, but it seems like too tedious, or you can't find the appropriate substitution. So the next thing to do is you can try to apply integration by parts. So in this case, how to do integration by parts, you need to understand first on how or what is the formula for the integration by parts. Okay, so let's start with this simple one. Okay, if you notice in these examples, x is one function, ln x is another different function. Second example, x, another function, times ex, another function. So basically, this example shows that we do have two functions that are multiplied to each other. Okay, so it means that you can use the integration by parts. So in other words, these examples, integration of x ln x dx, integration of x ex dx, integration of ex cos x dx, okay, they are actually in the form of u dv, integration of u dv. So either these two, x or ln x, x or ex and cos x, either two of them can be the u and can be the dv. So how can we appropriately choose which one is u and which one is dv? So we will discuss this further after this. How to get the formula for integration by parts? So if you still can recall the previous differentiation technique, which known as implicit differentiation. Okay, so we try to do implicit differentiation here, dy over dx, and then we differentiate d over dx for the uv. So since these two are multiplied, okay, so you can use the product rule. So how? Very simple, u times dv dx plus v du dx. Right, it's like u v prime plus v u prime. Okay, now next things, okay, if we want to get back this function or equations here into the original one, we have to integrate it. Am I right? So when we integrate the dy over dx, it means that we need to integrate the other side too. Okay, left side and right side. So when we integrate this one, integrate u dv over dx plus integrate v du dx with respect to dx. So in this case, we can cancel this. Yeah. And then, okay, I may need to erase this area. Okay. Next, what we have is that when you integrate dy over dx, you will get the y. Yeah, agree? Right? Yeah? You will get y, which is equals to uv. Alright, so then what's left on the other side, okay, the right side is u dv plus integrating v du. Okay, now since we want to know what is the integration of u dv, so u dv, right, you will get by rearrange this. So the final representation of the formula is uv minus v du. So we bring the plus v du to the other side, it becomes minus. So this is your final formula for integration by parts. Okay, so I just show you how to get the integration of u dv equals to uv minus integrate v du. So this is what we call as the formula for integration by parts. Okay, now how to pick u and v prime? Okay, dv is v prime. So the first thing is that the u must be easy to differentiate. Okay, the second step is, alright, the second step is the v must be easily obtained from dv, whereas the v du, so where is the v du? So v du is another term that on the right side of the integration by parts formula must be simpler than u dv. Okay, so there is a rule of thumb that you can use. Okay, the acronym, you can call it LIAT, right? LIATE, whatever suits you. Okay, alright, so you need to choose u to be as the type of the function that appears first in the LIAT. So LIAT is defined as L is logarithmic, which consists of either ln x or log 2x. I is the inverse trigonometric. Okay, later on you will learn on this part in chapter 4, okay, which is inverse tangent or arctangent or arcsine. Okay, the next is the algebraic term x, 3x squared, then trigonometric, sin x, cos x, and exponential, ex or e2x, and so on. So the u, okay, according to this formula, whoever appears first. If in this question, for example, in this example here, okay, we see the x ln x dx. Okay, so we have the ln x, so the ln x will be your u. Okay, is that clear? Alright, so let's have a look into example 3.15. So example 3.15 is you need to evaluate the integration of x cos x dx. Okay, so you can refer to page 81. Yeah, so we already obtained or learned how to get the integration by parts formula, which is this one. You need to remember it because it is will not be given during the final examination. Okay, so integration of u dv is equals to uv minus integrating v du. Now you need to remember the Liat formula. Whoever comes first in this order should be picked to be as u. So we have ln or log, we have inverse trigo, we have algebra, we have trigonometry, and we have exponential. So back to the question here, we have x and cos x. So x is algebraic expression, whereas cos x is trigonometry function. Okay, so according to this rule of thumb here, who appears first? It is A, the algebraic. To B, it comes A before the T, the trigonometry. So in this case, you definitely now know that you need to pick U to be as X, so that your dv will become cos x. Okay, this is the first step. Next to do is you need to, once you already select the appropriate u and dv, okay, u and dv, so the next thing is you need to differentiate the u, so you'll get dx, and integrate the dv. You integrate the dv, it means that you integrate the cos x. You will get what? Yeah, sine x. Because if you differentiate sine, you'll get cos. Now, if you integrate cos, you'll get sine. Okay, clear? Now you can plug in all these into the formula here. Okay, so u times v. So u times, where is your v? Okay, this one is v. Okay, so u times v is x sine x, alright, minus integration of the v, which is sine x, and du is dx. Is that your final answer? No. You need to integrate this one. So x sine x, okay, that's fine over there. So if you want to integrate sine, you will get what? It should be cos x, because this one here is already negative. So plus cos x plus c. Is that clear? So if you differentiate cos, you will get negative sign. So there is already negative over there. Okay, so it should be plus here. So your final answer is x sine x plus cos x plus c. Okay, now let's move to another example. Example 3.16. Okay, integrate x ex dx. Okay, so what is u? Can you guess what is u? So we have algebraic and exponential. Algebraic comes first before exponential, so u must be the algebraic expression, which is x, whereas your dv should be e minus x. Okay, so again, you differentiate u, you'll get dx, and you integrate the dv, you will get, correct, negative e negative x. Okay, now you can apply it to the formula here. So you'll get u times v. Okay, u times v is negative x e negative x minus integrate the v, negative e negative x, and the du is dx. Right, so we just copy this one, the first part here, okay, and then what happens is that if you integrate this one, you'll get another negative ex, so negative, okay, you integrate this one, you'll get positive ex plus c. Your final answer will be negative x e negative x minus e negative x plus c. Alright, this is simple. So let's move to example 3.18. To example 3.18, still in page 82. So this example is quite interesting to be discussed with. We have ex sine x dx. So again, based on let here, who will be your u? Okay, so since this example is a combination of exponential and trigonometry function, so in this case you can either pick, okay, this is a quite special case actually, alright, even though the Liet says trigonometry comes first, so the u should be the trigonometry function, but it is actually much easier if you pick the e as u. So there is a special exception for this one between the trigonometry and exponential. Okay, you can interchange between two, either one can be the u. Alright, is that clear? So in our module, okay, it shows u to be, the ex will be u, okay, so the dv will be the sine x. So next thing, you differentiate the u, du will become ex dx, whereas the v, the dv, we integrate it, so you'll get v, it will become, okay, negative cos x. So if you differentiate, you always do this kind of, measuring action. Okay, think it in reverse for the trigonometry functions, yeah. So if you differentiate cos, you should actually get negative sign, but in our question there's no negative sign, that is why we have to put the negative here in your final answer. Okay, negative cos x. Now we apply it to the formula. Here you will get, okay, so u times v is negative ex cos x minus, okay, minus negative cos x for the dv, for the v, and the du is times ex dx. Alright, so if you look carefully, it seems that we encounter, alright, we encounter ex times cos, negative cos x. Okay, it means that you need to do, okay, another, okay, this one you still follow the process, okay, you still do the integration process for this one. So let me rearrange it. So nothing happened in this part, you just multiply it, but here, okay, I would like to take it out, the negative, it will become positive, okay, positive. So I would like to advise you to rearrange this one, so it become ex cos x dx, only then I integrate this one. Okay, I want to focus to this one first. So the u, okay, let me change it, the u is again EX, okay, the dV, let me erase this one so that you not get confused. So the dV is the cos X, okay, cos X dx. So the U du is EX dx, and the dV is, when you integrate it, you'll get sine X. Is that clear? Yeah? Okay, now let me erase it so that I have a ample space. Okay, from the previous one, okay, we did this one just now. So I copy the answer back to this. So this is the original one that we got, minus EX cos X. Please do not forget to write it down. Plus, so this is the second one, which is EX sine X minus, okay, UV minus V du. So V is sine X, okay, and du is EX dx. Now, if you notice, okay, we have already did it twice. Okay, now should we need to do another integral by parts process? Okay, actually you don't have to do that. You can stop it right there, since if you notice that this expression is similar, or exactly not similar, it is exactly the same as the original question here. So what you can do is that you need to move this part, oh sorry, too big, okay, forgot to change this. You need to move this part, okay, to the another side. Okay, what will happen is that, okay, so this is the original question, EX sine X dx. Okay, this is negative, right? Just now this is negative, so negative, when you bring it down here, you'll get positive EX, okay, sorry, EX sine X dx equals to, right, your answer here, negative EX cos X plus EX sine X. So this one you can add it up, okay, you can plus it. So what will you get is, okay, so this is 2 EX sine X dx equals to, okay, too big, the font is too big, I'll make it smaller, equals to, so I want to take out the same factor, which is EX, so EX times, alright, so it is sine X minus cos X, okay, right, I forgot this one. So your final answer will be, you need to bring, the next step is to bring the 2 here to be on the other side, on the right side. So your final answer is, okay, let me erase this one. So your final answer will be, okay, this is the original question, this equals to half EX sine X minus cos X plus C. Alright, is that clear? Half EX sine X minus cos X. Okay, although in my answer is not the same as the module, but if you try to make it simpler, you'll get the same answer like mine here. Okay, alright. Okay, now we move to another technique, which is integration by tabular method. So integration by tabular method, it is actually used to integrate the product of two functions. So for this technique, we usually apply it if integral by parts process becomes more tedious or it's getting complicated. For example, you have to integrate it more than 2 times. Okay, so once it becomes complicated, so this is where the tabular method can be such a helpful techniques for you. Okay, now such example, okay, when you want to apply the tabular method is when you find this kind of examples here. X power of n, so n probably higher than 2, times e a x n, okay, dx. Or you may encounter x power of n sine ax dx, or x power of n cos ax dx, where n in this case is much higher than 2. Okay, now in tabular method, you need to know that there is a reason why it calls tabular. Okay, it's in the form of table, which consists of 3 columns. The first column is sine column, okay, plus, starting with plus, minus, and so on. Okay, and then the second column is the derivative of u, so you still need to pick which one is u, okay, and which one will be the dv. So the third column will be the integration of dv. Okay, now let's have a look into example 3.19. X power of 4 times e 3x dx. So in this case, okay, since it has a combination, okay, of 2 different functions which consists of algebraic expression, which is x power 4, then and another, or the second function is the exponential. So we know that the u that you must pick is x power of 4. So this is your x power of 4, and your dv will be e 3x. The next thing you need to do is that you need to differentiate x power of 4. That will become 4x power of 3. Whereas this one, when you integrate it, it will become 1 over 3, okay, e power of 3x. Okay, so you need to do this process repeatedly until, since this is algebraic expression, you need to do it, okay, the hint is you need to do it until the x becomes 0. So let me finish up this one. So okay, so plus minus plus minus plus minus. Okay, this one, let me continue to integrate it. So the next thing is that, so make sure you finish up integrate this one. Okay, basically you must follow the right row as well. Okay, so let me draw the row for you. So this is the first row, this is the second row, okay, this is the third row, fourth row, fifth row, and sixth row. So basically we have 6 rows. Okay, so make sure they are tally with each other. So the next step is that you need to know how to complete the tabular method process. Okay, you need to draw the direction of arrow like this. So this one must times up with this. Okay, the first row of u times up with the second row of dv. So same goes to the rest. Okay, 1 over 3, 1 over 9, 1 over 27, 1 over 81, and then this is the final answer. Okay, you just need to write down the multiplication of each of the diagonal entries according to the arrow here. So I need a space, so let me delete this one.
To write the final answer, okay. So
our original question is x power of 4 is 3x dx, which is equals to, so we times up this one according to the arrow directions, right? So you just copy your answer here. Make sure you're not making a mistake. 1 over 3 x power of 4, okay, is 3x plus, sorry, not plus. Okay, we start with plus sign. So for the second row, we start with negative sign. So you need to put the negative sign following this, yeah? So the next step is negative 4x cubed times 1 over 9 is 3x. So let me finish up writing it down for you guys, okay? Alright, so the next things that you can do, you can try to simplify it wherever you can. So 1 over 3 minus 4 over 9, okay, this is already simplified, but this one you can do. It will become 4 over 9, right? The next thing is 24 over 81. You can simplify it. It will become 8 over 27, okay, and finally this one will become 8 over 81. Okay, I'm not going to write down the full answer here because you can refer to your module. Okay, so basically your module, okay, if you have it with you, your final answer will be like this, which is exactly the same like my answer here. Alright, is that clear? Just need to remember for tabular method, it's very easy. You need to draw the columns which consists of 3 signs, derivative of u and dv, and the signs must start with plus and then minus and then plus again and then minus, and it repeats until, if the u you pick is x power n, so you must differentiate it until 0. That is where you should stop your differentiation process. So the dv, the integrating process, just follow it until the last line where the differentiation is 0. Is that clear? Yeah. So let's have a look into another example. Okay. Another example for tabular method, which is example 3.20, page 85, you need to evaluate the integration of cos 5x sine 4x dx. So this one is a little bit different with the previous one because there is a product or multiplication of the trigonometry functions. Okay, so in this kind of example, it is up to you to pick which one to be the u and which one to be the dv. Okay, so you can pick sine 4x to be as u, alright, and the dv will be the cos 5x, okay, because both are the trigonometry functions. So again, this is the steps here. You need to write down the table, okay, with sine, derivative of u, and integrating of dv, and start with the plus sign followed by minus, and then the plus sign again. So I follow the module. So u is cos 5x, the dv will be sine 4x. So the next step is you differentiate the cos 5x, you'll get negative
5 sine 5x. Okay, I just want to finish up the u first, yeah? So cos 5x, negative 5 sine 5x, and then we differentiate it again. We will get differentiate sign, we will get cos, so this is 5x, times out 5, it will become minus 25 cos 5x.
So I just want to advise you again, when you come across with trigonometry functions, it is the best practice if you can master the chain rule in chapter 2 differentiation. Okay, that's why I can straight away differentiate it without need to apply the chain rule technique. As for this one, sine 4x, if you integrate it, you will get 1
over 4. Okay, this one is cos 4x. Since there's no negative here, because we know that if you differentiate cos, we get negative sign, there's no negative sign here, so we have to add negative over here. And then proceed, this will become negative 1 over 16. 4 times 4 is 16. Sine 4x. Okay, now,
How did I know that I must stop here? No need to differentiate further. Okay, the reason is that we encounter the cos 5x as the original function here. So we start with cos 5x. So when you differentiate it, you will need to stop when you come across with cos 5x. So another example, okay, if you start with sine 4x, so you need to stop the differentiation process of u when you come across with sine 4x. Okay, is that clear? So the integration process will follow and stop where the differentiation of u is stopped as well. Okay, now this one, the arrow directions also a little bit different with the previous example. So previous example, we have algebraic expression times up with the trigonometry function. So we have to differentiate until 0 for the algebraic expression, am I right? And then the direction of arrow, okay, just times up like this until the end. But for trigonometry functions, for both exist trigonometry functions, you need to do like this. This one you times up like previous one, but here, okay, the final one must times up with, okay, with the dv here. Okay, just remember the process is like this. Okay, otherwise you will not get the same result or the same answer.
Minus 1 over 4 cos 5x cos 4x. Okay,
The sign, the next sign is negative. Okay, negative 5 sine 5x times negative 1 over 16 sine 4x. Negative is positive, so you'll get
5 over 16 sine 5x sine 4x. Okay, and the last one is
plus, okay, minus 25 times minus 1 over 16, you'll get positive. Okay,
cos 5x sine 4x. Okay,
this one with exception, yeah, the last term here. So since we are not getting any 0, okay, so you have to put the integration function there. So you can see that this is not the final answer yet until you rearrange this part here. Okay, this part here, you need to bring it to the other side, which is this side. So you rearrange your answer. So cos 5x sine 4x dx minus 25 over 16 cos 5x sine 4x. So let me write down cos 5x sine 4x dx. So we bring down, okay, the 25/16 cos 5x sine 4x dx on the left side. So it will be equals to
negative 1 over 4 cos 5x cos 4x minus 5/16 sine 5x sine 4x. Okay.
Now the first thing is that we need to settle this part first. Okay, so this is if you want to subtract 25/16 cos 5x sine 4x from this function, so it will become, right, 16/16, okay, minus 25/16. This is integration of cos 5x sine 4x dx. Okay, so this one is still equal this. Okay, let's settle down this one first. Okay, 16 minus 25, you'll get minus 9/16. Integration of cos 5x sine 4x dx equals to
Negative 1 over 4 cos 5x cos 4x minus 5/16 sine 5x sine 4x. So
next thing is that you need to bring this part and times up with this, and also with another function here. Okay, so what will you get is that, so the integration of cos 5x sine 4x dx is equals to, so you bring the 16 over here, this is the division, so when you bring it on the other side, it will become times up with this function, so times negative, so you need to bring the negative as well. Okay, 16/9
cos 5x cos 4x, and then this one is negative 5/16 times negative 16/9 sine 5x sine 4x.
plus c. So your final answer will be, this one you can cancel out, okay, as well as this one. So negative negative will become positive, so it is 4/9 cos 5x cos 4x, and then this one is negative negative will become positive, plus 5/9 sine 5x sine 4x plus c. So yep, this is your final answer for this question. Okay, so stay tuned for my next video, which is on integration by partial fraction.